Okay, so we just saw that the actual output of a transformer is a probability distribution, which is essentially a score for every token in the vocabulary. And those raw scores are called logits. Now, to actually turn those logits into probabilities, we use an algorithm called softmax. And this makes it so that all of the probability scores across every single token add up to 1. From there, the model doesn't pick the most probable top token, it samples. And as we saw in our example, there was a temperature variable. A low temperature results in a very predictable output distribution, and a high temperature value results in a more creative, less predictable distribution. For instance, if we pass a temperature of 0, the transformer would predict the exact same token every single time. And then a higher value, like 1.5, will be much more random and sometimes incoherent. And then our other parameter is top P. And this is essentially a cutoff. So only sample tokens covering a certain percentage of the probability distribution. So a value of 1 means give every possible token a chance. A value of 0.2 means only the top 20% of tokens are considered. It essentially shrinks down the possible list of next tokens. And those two parameters are how we can get different outputs from the exact same input prompt. Now, everything we've walked through so far, tokenization, embeddings, the transformer layer, softmax sampling, produces one single token. To get the next token, we append the token to the input and then run this entire process again so we get new attention, new distribution, new predicted token, append, repeat. And this whole process is known as autoregressive generation. Essentially, the model has no plan. It doesn't know how the sentence ends when it starts. So every coherent paragraph from an LLM emerges one blind step at a time.